welcome to the Bite Size Trust bi-weekly meeting. We've now rescheduled. And reminder that we are all members who have signed the agreement and antitrust and not to stick to the agenda. And the agenda is looking at previously written videos and discussing future videos. Drummond?
I have an immediate question.
Yes.
So how could we get together at Bite Size Trust and actually do some kind of antitrust action? How could we do it? How could we subvert
Bite Size Trust and
at
make
Bite
it
Size Trust? Yes.
to make it we could say how to manage your password, and then we could say use the same one and pick something simple like 1, 2, 3, 4.
And send it to us and we'll tell you if it's a good one. Sorry, just
That's the best I've got. So
a little bit of a silly mood here. That's it. There's something about the antitrust notice for Bite Size Trust. It's like, how would we actually subvert that?
It just as an interesting note, the Louvre, did you see that the password on the security cameras for the Louvre Museum was Louvre?
You're serious?
Yeah. Not that it really matters, because like they point out, most crime is not happening with like the computers and the hijacking of the system and the lasers and stuff. It's a smash and grab. You go in, you smash it up, you grab something and you run. That's the classic XKCD comic of his intense cryptography, and they beat him with his $5 pipe wrench until he tells you the password.
Yeah. $5 pipe wrench, yes, exactly.
So with that, unless someone else, I would get into the 6 videos here, because then they're going to be ready for release. I'll get feedback and then I can edit them and potentially release the videos. Unless we wanted to discuss something else first. Okay.
No, sounds great. I'm thrilled that for once I'm in a time zone where I can attend the meeting.
Yeah, that's right. Good to see you. Okay, I'm going to share the screen and do playthrough. Content only, share sound. You're gonna tell me how bad this sharing is, because I have that screen turned horizontal, you know what I mean? Not vertical. So I don't know how bad it looks for everyone else. Okay.
No,
it's just
okay.
Very normal. Okay. And now I've lost like everyone.
That's right, because we all got turned sideways.
Yeah. Okay, so here we go. No,
the only problem is it's kind of hard to reach
digital identity.
There we
Sorry,
go.
what?
No, it's fine. It was just too small to read. You obviously have a portrait screen layout.
Yeah. Okay. Can you see it now?
Yeah, it's full screen. It's very good. Love that logo.
Yeah, thanks, Scott. When we talk about digital identity, we often think of using a single cryptographic key, one private key used for a digital signature or to authenticate. It's simple and efficient, but it also creates a single point of failure and a significant potential risk. Multi-signature and threshold keys are designed to solve that problem. Instead of depending on one private key, control is divided among several. To authorize an action, sign a document, or authenticate, more than one key has to participate. In a full multi-signature setup, every key must sign before the operation is approved. In a threshold scheme, only a subset needs to, maybe 2 out of 3 or 3 out of 5. Think of it like a secure vault that can only be opened when several people turn their keys at the same time. This idea is also used with decentralized identifiers, or DIDs. A DID documents verification method doesn't have to contain just one public key. It can define more complex arrangements. For instance, it might require that 2 out of 3 keys sign before a credential is issued, or that both your personal key and a backup key held by your organization approve before control is proven. The benefits are significant. A single stolen key is no longer enough to impersonate you. Responsibility can be shared across an organization without giving any one person full control, and you gain flexibility. You can define security policies that fit your risk level. Maybe all keys must agree for critical actions, but only a majority for routine operations. Of course, distributing control adds complexity. Multiple signers have to coordinate, and systems need to be able to collect and verify several keys. But in high-stakes environments like finance, governance, or enterprise identity management, that added effort pays off in resilience. With multi-signature and threshold keys, control isn't concentrated in a single key, it's distributed, enabling identities that are not only verifiable, but also stronger, safer, and more resistant to compromise. Okay. Any comment on that one, or good enough to release?
I have two of them quickly.
Yeah.
The last one where you show the multi-sig threshold.
Yep.
The diagrams are
Resilience.
No, a little bit later. The very last screen. Yeah, that one. So they're identical.
Yep. You want me to? I can change that.
Oh,
I was
yeah,
just
like
thinking
highlight,
that.
like highlight the keys.
Highlight 2 or 3.
Yeah,
Okay.
exactly. Just change the highlight in the lower one to, yeah, exactly. And my other one is, being here in Sweden, I'm noticing everyone is of the same color.
Yeah.
Complexion.
Complexion, and perhaps we need a little bit more global.
Yeah. So
You sound like Goebbels saying that. I don't know.
I shuffle it all around.
Yeah.
So
But
this one is white, but the other ones, it's the videos. I have a moving average of all the.
I see.
So I have
I
a
noticed that too. But I figured the
question.
lady could be, something
The
pan
diversity.
Asian.
I could add. I could change people. That's not a problem.
So I have a question and comment that you could add to it. So in crypto language, they talk about shards.
Yep.
Okay, so that's something that you could add. And in traditional PKI, the threshold is typically the M of N.
Yeah, I've seen M and N. I wanted to avoid that for complexity, just to tell a simple story with pictures. But the sharding.
But that also can explain it. So you have you require 2 out of a group of, and maybe change the picture to say, have a group of like 5 little, people of varying, ethnicities, and then point to 2 and say that's that's the M and the group is the N, and it should be very easy to when you have that kind of picture. So
Yeah,
you say
okay.
you pick
If
I was to make a collection of minimum of 2 plus of a group of. And I think that will, if you have that picture behind it, it should be very easy to understand.
Okay, so I'll add the wording of M of N to a picture. And did I use the word shard in here? No. Oh, I don't want to if I can add it into a slide, it's a lot easier than adding it to the recording. Shard. Okay, I'll look about Eric.
I had, well, great job as always. I also just want to let you know, I was doing some Googling last week and some of your videos came up just out of the blue.
Oh, that's fun. That's cool. At least it's going somewhere.
Yeah. But that was just a comment. You said high stakes use cases or something, and you said finance and governance, and I was wondering if like governance is a little broader, or do you have a better use case that?
Yeah.
You say.
but in high stakes environments like finance, governance, or enterprise identity management.
Yeah, I didn't know what that means. Like, what do you mean high stakes? High stakes governance. So that was my, I didn't know if there's a better illustration you
Way
could
to
use.
say it.
And then the other thing is at the very last part of your video, you said safer.
Yes, I know.
I heard
Damn
safer.
it. Okay, I will re-record that one.
Did nobody else hear that? Safer?
I heard it.
I
was
heard
like,
it too.
this is
I heard
good
it. I figured
enough.
it's the way Canadians say it.
Safer.
Safer. Neil.
Just to add to Scott's comment, I would not change the diagram you've got. I would add an additional quick slide to explain M of N, because your slide showing the, must use all keys and 2 of 3
Yeah.
is concept, and then M of N is the explanation. So trying to cram too much into one slide always tends to delete
Yep.
one of the 2 messages. So it's a quick slide, and it takes only a few. This is also called M of N. Here's the M, here's the N. I mean, it doesn't need a lot.
Yeah. Okay. Okay, so then I can do something like insert. Good thing I'm getting much quicker at these pictures because I'm gonna just put this in as a placeholder so I remember to do it. I'll do something like that for the keys. And yeah, I was, and I just reused that one. What I was thinking of doing is move up. What about just something like that? So it's like it's there, it's a bit technical without changing the without
Well, if
yep.
it's literally called M of N, I would say this is also called M of N.
Oh, okay.
What? It's M of N. I don't know what you. N is the total population, M is the selection.
Yeah, 2 of 3. Yeah. Oh, it's N of N. Was
N,
that right? No, it's the other. I thought it was the other way.
N, yeah, I know.
Yeah, okay.
20 years it's baked into my head. What can I tell you?
Okay, so I've got that slide. I'm going to increase the diversity of the people involved, and since I'm going to be re-recording this, then finance. I thought governance was like usually governance is not just, we don't even call governance one person's decision. So I thought it was,
Mhm.
but if you had a better suggestion.
Yeah, I was thinking.
I would also say that it's whether there's multiple organizations or multiple parties.
Multi-party governance or something like that.
Of course.
Multi, you need multiple people to do things. If you're talking organizational, it's
Yeah,
always
but
going to be.
where do I put that? Where do you want to see
Well,
that?
You could do, well, instead of, you could say multi-party governance, you could say nuclear codes.
Okay.
Well, it's just any sort of multi-party organization, inter-organization kind of stuff. It's almost guaranteed to be M of N.
Okay. I'm highlighting so I know where I have to re-record. Okay. Okay, so I will make those changes and change the people. Sharding. Is sharding only for multiple keys, or is that a general concept that applies both to threshold and multisig?
Well, it's used to as opposed to people getting one full key.
Yeah.
The other aspect is getting pieces of a key that come together. That's
Oh, and I don't have that here. That's not, that's not and I did the picture wrong then.
No, I was going to say, honestly,
that's another representation.
That's
sharding,
another. Oh, I have sharding somewhere else.
I was going to say sharding, this is so clear on multi-sig, which doesn't use sharding, that if you're going to do
Right.
sharding, I'd suggest doing a different one.
Maybe
Scott's got a good point. It's very
Okay,
useful.
I
but-
have sharding on another. I have sharding on another thing. So okay, so
No, that makes sense because you're dealing with it doesn't deal with multiple keys. It's
yeah,
one key
one key split in. Yeah, yeah.
Okay.
Okay, so on to key pre-rotation, which is back here.
Keys in digital identities come in pairs, a private key and a public key. You keep the private key secret, usually stored in a secure digital wallet. The public key, on the other hand, is meant to be shared, for example, by publishing it in a decentralized identifier, or DID, document, so that others can use it to verify you. With these keys, you can do powerful things. You can authenticate yourself online and log into services without passwords. You can also digitally sign documents, such as a university signing degrees for its graduates, and anyone can check that signature against the public key. But there is a catch. If your private key is ever compromised, maybe your wallet gets hacked or the storage system is tricked, your identity could be at risk, meaning that someone could impersonate you online. That's why it's good practice to rotate your keys frequently. Retire the old one and start using a new one. In DID systems, these updates may be reported in the DID document data so that anyone resolving the DID knows which key is current. Still, that raises a problem. What if an attacker steals your key and performs the rotation before you can? Suddenly, they look like the rightful controller of your DID, and you can't reclaim control because the system now trusts their key. This is where key pre-rotation comes in. With pre-rotation, every time you create a public-private key pair, you also generate the next pair in advance, making sure to keep them secure and available for future use. Instead of publishing the full future public key, you publish a cryptographic digest of that public key, a commitment to the key pair you'll use next. Later, when you rotate, you reveal the actual public key, and anyone can check that it matches the digest you committed to earlier. Where this pre-rotation data is stored is specific to each DID method and is not part of the DID core specification. Some DID methods, like DID WebS and DID WebVH, support key pre-rotation, and other methods do not. With key pre-rotation, even if someone compromises your current private key, they can't hijack your DID because they don't know the next key you've already committed to. Where supported, pre-rotation makes key rotation predictable and tamper-resistant, securing DIDs against takeover.
Okay.
Ooh, you tackled a pretty tricky subject. I have a major complaint.
Yep.
You made
It's
it
white
easier.
again.
You explained it easier and better than we did in Carry for Muggles. So you've outsimplified.
Excellent. Good news. I mean, sad for you, but thank you.
This is good. We can just go back and replace it with go watch that video. Yeah, I gotta say that's pretty good.
Good. Okay. And I didn't say it out loud, but I say that it's kept more secure, like offline or something like that. Just kind of simple, but pointing it out.
Yeah, you can always, add a footnote about every time Sam Smith explains it, it's at the bottom of a coal mine.
Well, I know. I remember that still.
It sticks in their head. It's like, oh, where am I
It
going to
does
find a
stick
coal
in the
mine?
head,
Right
yeah.
all the way to the bottom.
Okay. Okay. Key, that's my work.
Semantic engines. When are you going to explain those to us?
Oh, we're trying gradually to build out an ecosystem for supporting data, better data management and stuff like that. So the semantic engine is what adds meaning to data.
No, it's all good. I know. I just was wondering,
Yeah.
is there a separate semantic engine?
Oh, a separate
besides
explainer video.
bite-sized semantic engines.
Cool. So keyword pre-rotations ready to go. Service endpoints. This is kind of a stupid one. Well, okay, I shouldn't poison the well, but it's a simple
Yeah.
thing, but I
When you
wanted
resolve a decentralized identifier, or DID, you don't just get back keys, you also can get something called service endpoints. A service endpoint is like the address book entry for your DID. It tells others where to reach you, what protocols you support, or which services you're connected to. For example, a DID document might list an endpoint for secure messaging with DIDCOM, another for credential exchange, or even a simple URL for a profile page. Each service endpoint is described with a type, an ID, and a URI. But here's an important point. DIDs themselves don't handle routing. They don't deliver your messages. Instead, service endpoints connect your DID world to existing infrastructure, like the internet, peer-to-peer networks, or even email. That's how messages actually get from point A to point B. So think of service endpoints as the bridge. The keys in your DID prove who you are, but the service endpoints tell others how to find you and which communication channels to use.
okay.
First reaction, for the non-did people in this world, it's
Yep.
your APIs.
What?
It's the APIs.
Oh, it's the location of the API. Okay.
That's right, because the stuff I'm looking at in terms of the travel profile stuff, everybody in the airline industry has APIs. So this is they'll get that. So this is
Right. Although I'm a bit concerned that API is already fairly technical. I showed my parents one of these videos. They were curious what I was doing, but they had no connection to the content that I was writing, so it didn't make any sense to them.
I
God's
feel
laughing.
To that, I do.
Yeah, Eric,
I was going to say I've got to run. I can only stay this first half hour, but great job, Carly. And
thank you very much. Thanks for the feedback.
good seeing everybody.
Bye.
See ya.
Okay.
See
Yeah.
ya. See ya.
I did have some feedback there.
Yeah.
Sorry, I'm also multitasking slightly. It was near the start. I think it was the graphic at the very start. There were just two of them here. Okay. I'm a little uncomfortable with DIDs contain authentication methods, quote, key, parentheses, keys. I know they use the term, verification methods, I guess,
Yeah.
right? Because they didn't want to come out and say keys, but verification methods are different than authentication methods.
Yeah.
So
Yeah.
I would, verification methods.
So I missed that. That's wrong. That's right.
Yeah, and then it's probably for bite-sized trust, probably find verification methods, keys, and service endpoints. Yeah, okay, that's much better. Thank you.
Okay.
okay. So as an audience looking at this for the first time, I'm confused by that keys and verification. What?
Yeah.
Verification?
Okay, you know what? You know what? I'm just going to keep it simple.
Okay. There you go. Thank you. This is bite-sized trust. You can
This is
do
bite-sized
that.
trust.
I would assume that the endpoints are providing verification methods.
No.
Well,
that's the problem, Neil, with the terminology they ended up choosing, which was over my objection, by the way, just so you know, I'm going on record about that. Because you do have keys, the service endpoints can have verification methods, and they decided to call any of the cryptographic material, cryptographic verification material in the DID document a verification method. They issued the term, public key or keys. And
Yeah.
so you might actually, Carly, in that first one, you might actually want to say cryptographic keys and service endpoints. Just,
Yep.
yeah. Yeah, there you go. Now I'm totally comfortable with it. Oh, I had one other suggestion on the second slide,
Yep,
which is just, you talked about 3 examples.
yep.
Um, oh, I know, it was the example.com messages,
I have no idea what the URLs would be for this, by the way. So,
yeah, actually, then I'll take it back. I was going to say typically in that second one, if it's didcom, then they usually put didcom someplace in the URL, but that's just a convention. It doesn't matter. It's fine. Forget
right.
that.
Okay.
I'm good.
I could do this. And then that gets that you could also use it for API connections without me
Actually,
saying it complicating. Yeah.
I was going to say in that case, you could do example.com/didcom and just all lowercase.
Is it 2 M's, 1 M?
2 M's.
Okay.
There you go. Now
I,
you've,
I,
go
all
ahead.
right, so I would suggest for the API is give it API_X. So it's not an API, you have APIs.
Yep. Okay.
Yep. Okay.
Good. I just want with this one, I really wanted to stress that because they're like, oh, I use my DIDs to connect. And then you think it's just DIDs, but no, it's DIDs because then you're like, anyway,
This one,
like
Carly, is a bite-sized trust after my own heart.
where to store
Yeah.
private keys or endpoints.
Well, yeah, and it just they get so much play about the keys, and that's super important. But I would argue that, in the end, what makes them really valuable is the endpoints.
Is the endpoints. Yeah.
Yeah.
So the only other thing I can think of is you're showing
Decentralized
three very different URLs.
Yeah.
That's
Why would
fine.
Yeah,
Yep.
it's just,
They are different.
It
And
is.
yeah.
I mean, Neil has a point. It would they would have like same origin, but I don't know.
No, but what if I was saying this is my LinkedIn, this is my Gmail?
Yeah, that's true.
Yeah, but the API I'm going to is probably your endpoint to find out that it's your LinkedIn, whatever. That's how I would structure
Maybe,
it.
but I was also putting that as not, I wanted those to be, I didn't want them to be a whole mix of things, because if it's all the same, then I feel like, oh, I don't have that. I just have it scattered everywhere. Yeah,
Well,
so
you might want to make that, well, maybe it's an additional quick slide, but explain, in many cases, you may be pointing to your endpoints are all different services you offer directly at your own URL or other services related to this,
yeah, okay.
which are on different systems, because, you say those are URLs out in the wild. They're
Yeah.
not controlled by my
Maybe for, I think then the next video that I would do, I would go into more depth. I wanted it to be
That's it. That's good.
Okay.
When you create a decentralized identifier, or DID, you end up with a pair of keys, a public key, which you share in your DID document, and a private key, which you must keep safe. So, where do you store your private key? Keys are generally stored in digital wallets, and wallets can be on the edge or in the cloud. Edge storage means keeping the key directly on your device. It might live in your phone's secure enclave, on a hardware security module, or inside a digital wallet app. The advantage? You hold the keys, no one else can touch them, and you can even keep your important recovery keys offline in an air-gapped secure storage for greater security. The risk is that if you lose your device and don't have a backup, you lose your keys too. The other option is cloud storage. Here, the keys are encrypted and stored with a provider. That might look like a custody service managed by your enterprise, or cloud-based wallets that sync across devices. The upside is convenience and recovery. If your phone dies, you can still get your keys back. But the trade-off is trust. You're depending on the cloud service to secure them properly. In practice, many digital wallets combine both. They store the key on your device, but back it up with encrypted recovery from the cloud. That way you get the best of both worlds, control on the edge and resilience from the cloud. So whether you choose edge or cloud, remember, the security of your private keys determines the security of your DID. Lose the keys and you lose the identity.
Okay.
So-
Neil.
So, so one assumption I've been making, particularly around the travel use cases, is a distributed wallet. Which means that it's not sitting on a single device, because if I'm in transit and I don't have Wi-Fi access and my flights have all been canceled, I would still expect, my cloud wallet to be able to interact with somebody trying to rebook all my flights. So
Yeah.
that's pretty, that use case just keeps coming up. So
Yeah.
give it a name across that a distributed wallet takes care of some of that, some of which can be completely offline.
Okay, you know what? I might do that as another bite-sized trust video then. Distributed wallet. Give it its own topic. Drummond?
And well, yeah, to Neil's point, the term I hear used the most for that is hybrid wallet. And I think it means the same thing you're talking about, Neil. It's just another term for it.
Okay.
No, I think, yeah, the intent there was strictly to, for the travel industry is you're not going to have them all, a hybrid wallet. It's you're going to have, to have that cloud wallet is going to be essential for a lot of them. So it's not on any single device. That, in other words, don't think about a wallet as something that sits on a single device, because that's not going to scale or.
Right, yeah, but the cloud covers that here and hybrid. So,
Yeah, it's true. The nuance, that's the thing. Of bite-sized trust. We don't worry about the nuances.
yeah,
A hybrid wallet that's designed to be used from any point works better than a hybrid wallet where it's just using the cloud for like backup. But it's more complex that way too.
yeah, okay, yeah. Because there's like cloud for backup, and yeah,
Yes. Anyway, I put my hand up. Well, actually,
yeah.
I guess my hand's down now and Scott's next, but I'll put my hand back up because there was something else earlier.
Okay, Scott?
I don't know, my hand was up for, the first time. So the one concept that you're skimming over that you need to address, since you're talking about storing private keys. So storing
Yeah.
private keys can be in three appearances, okay? One is in the, one is in the clear. The second
Right.
is encrypted.
Yep.
And the third is in a hardware device, and you don't really get into that. You just say it is,
Yeah.
but hardware device, you need to explain in a bite-sized trust is that it's tamper resistant. It has, and that's a big advancement by the smartphones. And you can mention that, now we have tamper, we have chips on those.
Okay, so I want to make that into a separate video. While we're
Okay.
here, what is that video called?
Well, it's protecting private keys, maybe. So,
New video. Okay, and it was one
when you store it in the cloud and you
clear.
store it on the phone, that's one thing. But if you store it on your phone and it's native, or you store it in the cloud and it's, it's clear, then it doesn't really help the scenario. So,
Okay, so you can store, okay, so protecting private keys, you can store it clear where it's at risk but accessible. You can store it encrypted where it's secure, but you have to decrypt it before you can use it. And then hardware specialized modules.
it's hardware secure modules, really what they
Right.
create. And
In which
Hardware-
case,
hardware, and that can be
as
a
a
chip.
rule, Scott,
It can
Scott,
be.
isn't it true that if you store it in one of those, you can't get it out?
Yeah, and
Okay.
so it's important to say that you have that available in the smartphone now.
Yeah,
And the only way you can get that in the cloud is if it's stored in a hardware secure module in the cloud. So they do have vehicles that you can now, you have HSMs that you can attach to for cloud services that
okay.
are yours.
And that's what I noticed early on, Carly, on this slide, the one you're showing,
Yeah,
you mention an HSM. HSMs are not on the edge.
They are actually. So
and my phone it
What?
would be.
PE is considered.
I've never heard it called an HSM on the phone.
It is. So the chip is because an HSM is actually a chip on a card.
Right,
That's-
but have you ever heard, I've never heard that term used for, I've heard secure enclave or, but
Secure enclave,
every time I
that's
hear HSM, in fact, I'm gonna go check the Wikipedia page and see if it says anything about it. It's just, it's
Yeah.
terminology.
well, HSM can be a chip or it can be a full device now. And the way that, in Web Trust, they say if you get a card, you get a smart card, the card can, the chip on the card is an HSM.
Is this an HSM?
What? What's an
YubiKey.
No, that's not an HSM. No, that the YubiKey is a device that that's really for multi-factor. It's not, I don't know if it's tamper evident or not. I don't.
I think
Okay.
YubiKeys are now. They didn't used to be, but I think they are.
YubiKeys may have. Let me see. You may get a YubiKey.
It's certain, if it isn't, I suspect they soon will make it.
Yeah.
Yeah. So
Right.
you can YubiKey.
Okay.
Yeah, you can.
So
Yeah.
do I need to change something in this video? I mean, there's definitely more to talk about. And I want to put protecting private keys as a separate
By the
video.
way, the chip on the YubiKey. I
Yeah.
think if you get a more expensive one, to 650, is considered an HSM.
An HSM. Okay.
Okay, I stand corrected.
UBHSM, that's what they call it. And it's a chip, that's all it is. So it's a module, which, the chip is hardware tamper evident that meets FIPS 140 dash.
Yeah, just a quickie. I looked up on Ubicom, and they're certainly talking about hardware secure storage modules.
Okay.
Yeah, but not all
Yeah, but-
YubiKeys that way. You have to get an extra, it's
Right.
a-
Okay. Okay. And that
Yeah.
would be on the edge.
Well, okay. Yeah, okay. You're right. It is on the edge that way.
And
Oh,
it's,
I guess,
it's also what crypto uses it. You get a little dongle there. It is.
oh yeah,
considered,
you're right. You're right. You're right. That can be, I guess as soon as I hear edge, I think, mobile phone and
Right. But the TEE, which is the chip on the trusted environment and
execution environment. Yeah,
has a smart chip in it.
right. Okay.
Okay. That's a whole other video. I want to do that execution environment. Yeah. So other than this being simplistic, a simplistic introduction to private keys on the edge and in the cloud, and or that you could have both. Is there anything else that I want to talk more about protecting private keys? I think that's a neat topic that I didn't know so much about. And so is this one good enough to stand? As a simple story. And then I talk more in other videos.
Yes.
Okay.
You got to start simple. I mean, you're gonna start from a base and build to the more complex, right? So
Yeah. Yeah. Okay, good. And I got a new idea for another video. I was like, oh, I'm getting to the end of my topics that I really want to talk
There's
about.
no end to the topics. There's no end.
Okay, then on to the last one. Where just storage and recovery of keys.
When you create a decentralized identifier, or DID, the most important thing you have is your private key. If you lose it, you lose control of the identity. So how do you keep it safe without making it impossible to recover? That's where hybrid storage of your private key comes in. Instead of choosing between edge storage or cloud storage for your private keys, you combine them. For example, your wallet might store the key securely on your device, but also back it up in the cloud, encrypted so only you can unlock it. But what if you forget your password or lose access entirely? That's where social recovery adds another layer. Imagine splitting your recovery key into pieces and giving one share each to a few trusted friends or to devices you own. No single person can unlock your identity, but if you collect enough shares, say 3 out of 5, you can reconstruct the key and recover your DID. This way, you're not relying only on a cloud provider, and you're not left stranded if your phone dies. Hybrid storage with social recovery blends convenience, resilience, and trust, making decentralized identity practical for real-world use.
I used shares instead of shards. Should I switch it to shards?
I've heard both terms. I thought that,
Okay.
yeah, it was great. Yeah. It's funny because it yeah, I like the fact you do cover the same topic a little bit in multiple videos, which you have to do when you're explaining stuff like this. So yeah, that was good.
Okay.
The only thing I can think to do is to you know, the method is also called sharding.
Okay, I could, maybe I'll add that into rather than
I would put shards in quotes just to make it clear that it's a specific term.
okay. Okay. Good. Okay, good. That then in the last 10 minutes, so those are, I have to do some re-recording. Thankfully, just on the first one, that's always the microphone work is more work than the slides. Then those would be ready for publication. And ongoing scripts, I still have DidCom in the hopper, but I need to talk with somebody specific about DidCom to make sure that this is correct. And then in script ideas, Scott, you want to work on some governance scripts, or do you want me to have a stab at it and then you edit
I
it?
still need to do it, you know, and I think actually this is the first week that I can focus some energy on that. So
Okay.
I will come up with the script and maybe need help with the graphics.
Yeah, I can do now. Once I get my PowerPoint language of slides, that is pretty quick for me to generate content. So I can, yeah, I can do that. And I wanted to do another video about zero knowledge proofs because that comes up a fair amount.
Oh
Oh.
boy.
Yeah.
The bite-sized trust explanation of zero knowledge proof. You do a great job. It will totally blow out all your other.
Well,
It,
let me
it'll go
just throw a
viral.
pitch in for zero knowledge proofs. The current maxim is to use a mathematically limited formula, which is only good for proving certain numerical sequencing things. But the concept of zero knowledge proofs is I have an independent third party that is a trusted certified component that can
Yeah.
do just about anything you want without having to go to any additional gymnastics.
Yes. Yeah. But your trusted third party is math.
Well, your trusted third party about the certified component is math. But what its
Yeah.
capabilities is not limited to the current limited mathematical cryptographic ZKP, which has also
Right.
got a very high, the other problem with ZKPs is they're very expensive to run.
Yeah.
So
That is changing. I just left a meeting about that today.
Oh yeah.
I
Okay.
know, but it still doesn't address the limitations of the math.
Uh, when you say the limitations of the math, I'm not
Well, my
sure.
understanding, and it's probably completely naive on my point, but anything I've heard about ZKP mathematics is if you don't have something that's in a numerical sequence, like if I ask a question, are you married and, you have 3 kids and something else, and you're a qualified member of this, if I want to ask you a multiple logic question that's not in a numerical sequence, like,
Oh,
are you over
Hmm.
18 kind of question, then you don't have a vehicle to do that with that algorithm. And there may be a
That
whole
is
series of things that falls into that category that, if you're looking for.
Okay.
that is yeah, that is definitely changing. Again, I'm not a cryptographer, but um, the uh, the CTO of the Siros project, siros.org, is here in Sweden, and I came to meet with him, and he arranged for the guy that's working on ZKP for the European Digital Identity Wallet to meet with us, and he explained exactly the innovations, two of them that they've been working through that would generalize the math and make it a lot more compact and fast. And these are not minor things. It was like the ZKP community's been trying to solve this stuff for a long time. So I was like, oh my God. By the way, I'm just sharing that with this small group. I
Yeah.
mean, it's fine if this is being recorded. I'm not giving him any secrets or anything. But it
Yeah.
was exciting to see that, Neil, that those two constraints are potentially both getting
Okay.
dealt with.
Well, it just struck
Okay.
me that ZKPs are a solution-driven requirement. I have this neat technique, so I'm going to apply it to everything. So
Yeah, but
Well,
I'm sure there are requirements where it's a realistic thing rather than the
what's
latest toy.
what's driving that requirement right now, and the reason this work is happening is because the European Digital Identity Wallet legislation requires unlinkability. And
Mhm.
the only two ways to achieve it that folks have come up with is batch issuance or ZKP. And batch issuance is turning out to be very expensive and a real pain. And so folks are now clamoring for ZKP.
Batch issuance, is that, I remember Sam was talking about that in a Cary meeting, I think, where they just made a whole, issued like 10,000 credentials into a pool so that you weren't always the next one to
No,
be, that's
it's much
different.
simpler than that. It's
Okay.
basically issuing you more than
Oh,
one credential. It's as many as you need, and you only use them once. So you can't. That's how you avoid being linked.
oh, yeah, okay, okay, yeah,
But
yeah,
it means, and interesting enough, it intersects with exactly what we were talking about earlier. The EU Digital Identity Wallet also wants hardware binding, meaning they want it bound to the keys in those HSMs. Well, to do that, you're going to fill up. There's only so many of those you can do. So it means that the
right.
companies want to support hardware binding of for European citizens with gazillions of credentials for batch issuance are going to have to spend a fortune on HSMs, and they're going, no, 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 that's too expensive. Give us ZKP. So, and with
So
that said,
my,
I have to leave 5 minutes
yes,
early because I'm supposed to join 5 minutes early for an LFDT webinar.
okay,
So,
well,
and
thank
I'll
you.
do the whole time as I'm going to say, you don't listen to me, just go watch all of those bite-sized trust videos. That's much better than anything I could share with you.
Thank you. Best of luck. And yeah, we're gonna play them. Uh, whenever you leave Drummond, but just of interest to everyone else, I've been working with Ben about redoing the web page for Trust over IP. First of all, I'd like permission to just go through and rework the whole web page. And second of all, he's redoing the web page to make Bite Size Trust a better web page on
So are
that.
you saying the bite-sized trust webpage or the whole site?
No, I think the whole site needs a rework.
I think it does too, but how soon are we trying to do that? I hope not before the symposium.
Not before the symposium.
Okay, I'm
Just
totally
the
on board with
bite-sized
that.
trust page before the symposium.
I would actually say it's not quite as urgent as getting out a new version of our introduction because that's way out of date. And I'm going to be working on that this weekend. But you're right, we do need a new site.
Okay,
So, all
good.
right,
Thank you very much, everyone. Thank you.
you bet. I'm going to jump early. Great to see you all.
Yeah.
I will be back in the States with fingers crossed and not too delayed flights by the end of the day tomorrow.
Right. Best of luck. Bye,
Bye all.
everyone. Thank you.